14th of April 1943. Cold gray Atlantic water. Lieutenant Commander Vincent Astor stands on the deck of a rescue vessel, watching bodies float past. He is a naval intelligence officer assigned to convoy protection analysis. The men are merchant sailors. Their ship went down 8 minutes ago. The hull is still visible, capsized, trapping dozens more below. Astor counts the dead and writes in his logbook. He has seen this pattern 17 times in 3 months. Ships that should sink are not sinking fast enough. Men who should escape are drowning inside steel coffins. Astor is 51 years old. He is wealthy, a hotel heir, but he volunteered for naval service in 1941. The Navy assigned him to study convoy losses. His job is to find patterns in how U-boats kill merchant ships. He expected to track torpedo angles and convoy formations. Instead, he has discovered something worse. The ships are killing their own crews. The problem is simple. Merchant vessels carry watertight compartments. These compartments are designed to prevent sinking. When a torpedo strikes, bulkheads seal automatically. Water floods one section but not others. The ship stays afloat longer. This sounds like good design. It is not. The sealed compartments trap sailors below decks. Hatches jam, ladders flood, darkness comes fast. The ship rolls slowly onto its side. Men inside have no way out. They drown in pockets of air as the vessel capsizes. The ship that was built to save them becomes their tomb. Astor has the data. He has interviewed 340 survivors. He has read 89 after-action reports. The numbers are clear. When a merchant ship takes a torpedo hit, crew members have an average of 8 minutes before the vessel capsizes. In those 8 minutes, men below decks must reach topside and abandon ship. But watertight doors seal within 90 seconds of impact. Flooding is contained. The ship stays level longer but becomes a maze of locked compartments. Sailors trapped below cannot open the doors. They cannot break through steel. They wait in darkness as the ship tilts and the water rises. Astor calculates the death rate. In ships with fully functional watertight systems, 71% of crew members below decks at the time of torpedo impact do not survive. In ships where compartments fail and flood rapidly, only 23% of below-decks crew die. The ships that sink faster save more men. The conclusion is unavoidable. The safety system is causing the deaths. He writes a report. He submits it to the Office of Naval Intelligence on 3rd of May 1943. The report is 47 pages. It includes diagrams, survivor testimony, and a proposal. Astor recommends installing controlled flooding valves in all merchant ships. These valves would allow crew members to deliberately flood compartments from topside. The ship would sink faster, but it would sink upright. Crew below decks would have clear escape routes. The vessel would become a stable platform for evacuation instead of a rolling trap. The response is immediate and hostile. Naval architects reject the proposal. They call it heresy. Ships are built to stay afloat. Deliberate sinking violates every principle of maritime design. The chief constructor at the Bureau of Ships writes a memo. He states that Astor's plan would encourage panic and premature abandonment. He argues that keeping ships afloat gives rescue vessels more time to reach survivors. He says that controlled flooding is operationally unsound and psychologically dangerous. The memo is filed. The proposal is denied. Astor does not stop. He has access to convoy commanders. He has relationships built through 2 years of intelligence work. He contacts Rear Admiral Wilder Dupuy Baker, commander of convoy and routing. Baker is pragmatic. He cares about results, not doctrine. Astor shows him the numbers. Baker authorizes a trial. In June 1943, 6 merchant ships are fitted with Astor's system. The system has 3 components. First, manual flood valves installed in each watertight compartment. These valves can be opened from topside by turning a wheel. Second, timed scuttling charges placed in the lowest holds. These charges are small, just enough to rupture hull plates. They are set on 10-minute delays. Third, new evacuation protocols. Crew members are trained to trigger flooding immediately after torpedo impact. The goal is to sink the ship in a controlled manner, stern first, keeping the bow elevated as long as possible. The first test comes on 22nd of June 1943. The merchant ship SS Samuel Huntington takes a torpedo hit at 3:40 hours in the mid-Atlantic. The torpedo strikes the number 3 hold on the starboard side. The explosion kills 2 men instantly. The captain, James Harrell, is on the bridge. He follows the new protocol. He orders the flooding valves opened. He activates the scuttling charges. He sounds abandon ship. The crew moves fast. Men below decks have clear routes because the compartments are flooding evenly. There is no capsizing. The ship settles slowly, stern down, bow up. The angle is stable. Lifeboats launch without tangling. Rafts deploy cleanly. The crew has 14 minutes before the bow goes under. All 38 surviving crew members reach the lifeboats. A destroyer picks them up 4 hours later. 0 additional casualties. The system works. Astor compiles the data from all 6 trial ships over 3 months. 4 of the 6 ships are torpedoed. All 4 sink, but crew survival rates are dramatically higher. In the 4 torpedoed trial ships, 89% of crew members survive. In comparable ships without the system, only 52% survive. The difference is 37 percentage points. Astor calculates that if the system is installed fleet-wide, it will save approximately 2,800 lives per year based on current torpedo attack rates. He submits a second report on 15th of September 1943. This report includes the trial results and a revised proposal. He recommends immediate installation of controlled flooding systems on all Liberty ships and T-2 tankers. He estimates the cost at $1,200 per vessel. He provides installation timelines and training schedules. The report goes to Admiral Ernest King, Commander-in-Chief of the United States Fleet. King reads the report. He does not like it. King is a traditional naval officer. He believes ships should be built to survive, not to sink. But King is also a realist. The Atlantic War is brutal. Merchant crew losses are unsustainable. Experienced mariners are irreplaceable. Training a new merchant sailor takes 6 months. Losing a veteran crew means losing institutional knowledge that cannot be rebuilt quickly. King approves the program on 29th of September 1943. He orders installation to begin immediately. The program faces resistance. Shipyard workers do not understand why they are installing equipment designed to sink ships. Union representatives file complaints. They argue that the system will be used to scuttle damaged ships prematurely, costing jobs and cargoes. Astor travels to shipyards in New York, Baltimore, and Norfolk. He meets with workers and union leaders. He shows them the survival data. He explains that the system saves lives, not ships. The complaints continue, but the work proceeds. By December 1943, 340 merchant ships have the system installed. By March 1944, the number reaches 890. The system becomes standard equipment. Crews are trained in the new protocols. The training emphasizes speed and discipline. The key is to trigger flooding immediately before the ship begins to list. Hesitation is fatal. The system only works if used fast. The results are measurable. From October 1943 to June 1944, 127 merchant ships with the controlled flooding system are torpedoed in the North Atlantic. Of these, 119 sink, but crew survival rates average 88%. In the same period, 94 merchant ships without the system are torpedoed. Crew survival rates average 54%. The difference is 34 percentage points. Astore's system reduces crew casualties by 64%. The numbers are reviewed by the Office of Naval Intelligence and confirmed by the War Shipping Administration. The system saves lives, but it costs ships. Vessels that might have stayed afloat long enough for towing are deliberately sunk. Cargoes that might have been salvaged are lost. The economic cost is significant. But the human cost of not using the system is higher. Britain's supply lifeline depends on experienced merchant crews. Losing ships is acceptable. Losing the men who sail them is not. Astore continues his work through 1944. He refines the system based on feedback from surviving crews. He adds redundant controls for the scuttling charges. He develops better training materials. He visits convoys and speaks with captains. He collects data on every torpedoed ship. His reports are detailed and relentless. He does not celebrate the success. He counts the lives saved and the lives still lost. The system is better, but it is not perfect. Men still die. Ships still sink too fast or too slow. The war continues. In May 1945, the war in Europe ends. The U-boat threat collapses. Merchant ship losses drop to near zero. Astore's system is no longer urgently needed, but it remains in place. The controlled flooding valves and scuttling charges stay installed. They become part of standard maritime safety equipment. Post-war reviews credit the system with saving approximately 3,100 merchant mariners' lives between October 1943 and May 1945. Astore is promoted to commander. He receives a Legion of Merit. The citation mentions his contributions to convoy protection and crew survival. It does not mention the controversy or the resistance. The official record is clean. But Astore's personal papers, donated to the Franklin D. Roosevelt Library in 1959, include the rejection memos and the angry letters from naval architects. They include his handwritten notes from shipyard meetings and his calculations of lives saved per dollar spent. The papers show a man who understood that saving lives sometimes means accepting losses that feel wrong. The controlled flooding system is quietly removed from most merchant ships in the 1950s. Peacetime shipping does not face torpedo threats. The equipment is expensive to maintain. The training is complex. The system fades from use, but the principle remains. Modern maritime safety protocols include controlled flooding as an emergency option. Damage control teams are trained to flood compartments deliberately when capsizing is imminent. The idea that a store fought for, that sinking a ship can save a crew, is now accepted doctrine. Vincent Astor dies in 1959. He is 67 years old. His obituaries mention his wealth and his philanthropy. They mention his naval service. They do not mention the flooding valves or the 3,100 lives saved. The system he built is forgotten outside naval engineering circles. But the men who survived because of it, the merchant sailors who escaped from sinking ships that stayed upright long enough for evacuation, they carried the memory. Some of them wrote letters to Astor after the war. The letters are in his papers. They are short and factual. They say thank you. They say the system worked. They say they are alive because someone understood that the ship was less important than the crew. The lesson is simple. Safety systems can kill. Design choices made with good intentions can create traps. Saving lives sometimes requires accepting losses that violate instinct and tradition. Astor saw the pattern. He counted the dead. He built a solution that felt wrong but worked. He fought resistance from experts who valued ships over sailors. He won because the data was undeniable. The ships that sank faster saved more men. The controlled flooding system was heresy that became doctrine. It was a paradox that saved 3,100 lives by embracing the thing it was built to prevent.